Dear students, this is the 10th class of Fourier transformation. In the previous class, we have did some examples on the Fourier sine transformation. Let us continue some examples on the Fourier transformations and inverse of the sine Fourier transformations. So find the sine transformation of 2 times of e to the power of minus 5x plus 5 times of e to the power of minus 2x. Now to solve this problem, let us use the one property of the Fourier sine transformation, that is use fs of af of x plus bg of x is equal to afs of f of x plus bfs of g of x, a linear property. To find fs of 2e to the power of minus 5x plus 5e to the power of minus 2x is equals to, here compare this and this, wherever a is there 2 is there, wherever b is there 5 is there, that's all. Here you write here in this, and 2 times of fs e to the power of minus 5x, f of x is here 5x, then 5 times of fs e to the power of minus 2x. Now fs e to the power of minus 5x, using the definition of the Fourier sine transformation, we can write 2 this constant as it is, square root of 2 by pi integral 0 to b e to the power of minus 5x sine alpha x dx plus 5 times of square root of 2 by pi integral 0 to b e to the power of minus 2x sine alpha x dx. By this you writing in here using the Fourier sine transformation. So here square root of 2 pi as it is, this 2 you multiply inside, 2 times of e to the power of minus 5x sine alpha x dx, then this integral as it is. So these are the these two integrals are standard integrals. So using the in the next, using this one, this integral value is 2 alpha divided by alpha square plus 5 square, and this 5 alpha divided by alpha square plus 2 square. Alpha common is there, square root of 2 by alpha, 2 divided by alpha square plus 25, 5 square is 25, 2 square is 4. So how will get this to this? I explained in the next slide here. Integral 0 to infinity e to the power of minus ax sin bx dx is, the formula is e to the power of minus ax minus a sin bx minus b cos bx divided by a square plus b square. This is the first integral, this integral value. This integral value we are find out here. Integral 0 to infinity 2 times of e to the power of minus 5x sin alpha x dx is 2 is as it is. Then using this formula, and then compare these two, wherever a is there 5 is there, wherever b is there alpha is there, that's all here right here. Then 2 times of e to the power of minus 5x minus 5 sine alpha x minus alpha cos dx integral 0 to infinity 25 plus alpha square. So this integral, you substitute the upper limit infinity here, the total it is 0, e to the power of infinity value is 0, e to the power of infinity minus 2 times of lower limit here, 0, sine 0 value is 0, alpha right as it is, cos 0 value is 1. So the infinity, e to the power of infinity value is 0, this minus into minus plus 2 alpha divided by alpha square plus 5 square. This value is here, 2 alpha divided by alpha square plus 5 square. Similarly, we can write the value of integral 0 to infinity 5 times of e to the power of minus 2x sin alpha dx is like this, 5 alpha divided by alpha square plus 2 square. Okay, one more example, simple example. Find the Fourier sine transform of the function cos x divided by root x. Let f of x is equal to 1 by root x. Then we have a f cap of alpha is 1 by root alpha. It is the reciprocal. We have by the shifting property, fs of f of x cos ax is 1 by 2 times of sf fs cap alpha plus a plus fs cap alpha minus a. This is, we have a property, then wherever f of x cos ax is there, fs is fs. Then f of x is 1 by root x here, 1 by root x. Then cos ax is cos x. Then you write in this form. Then 1 by 2, 1 divided by root of alpha plus 1 plus 1 by root of alpha minus 1. This is simple example. Next, one more example. Prove that x into e to the power of minus x square by 2 is the self-reciprocal under the Fourier sine transformation. By the definition of the Fourier sine transformation, we write fs cap alpha is equal to root of 2 by pi integral over the 0 to infinity f of x sine alpha x dx. Then root of 2 by pi as it is integral 0 to infinity is f of x value is here x into e to the power of minus x square by 2 sine alpha x dx as it is. The square root of 2 by pi integral 0 to infinity sine alpha x, then x into e to the power of minus x square by 2 dx. Using the integration by parts, sin x is the first function, this is second function. Then we sin alpha x as it is, then integration of this minus e to the power of minus x square by 2 minus integral sin of minus e to the power of minus x square by 2 alpha cos alpha x dx by using the integration by parts. Square root of 2 by pi as it is. Now substitute the upper limit is infinity here wherever x is there. This value is 0 totally. Then here will come alpha, here x is the variable, this alpha rate outside the integral 0 to infinity minus times of e to the power of minus x square by 2 cos alpha x dx. Then fs cap alpha is equal to root of 2 by pi alpha integral 0 to infinity e to the power of minus x square by 2 cos alpha x dx. This is called equation number 1. This integral has to be evaluated by Leibniz rule for differentiation under the integral sign. This integral as it is difficult for us. So using the Leibniz rule under integral sign method. So here take the substitution this. Let pi of alpha is equal to 0 to infinity integral over the limit 0 to infinity e to the power of minus x square by 2 cos alpha x dx. This part we are considering pi of alpha. So square root of 2 by pi. Then here what you have doing? Using the Leibniz rule. Leibniz rule what says means you can find the differentiation integration continuously. Square root of 2 by pi 0 again integral 0 to infinity minus e to the power of minus x square by 2 cos alpha x dx. Then here this is continuation is there actually. This part is continued up to this. Then let f pi of alpha is equal to 0 to infinity e to the power of minus x square by 2 cos alpha x dx. Differentiate this with respect to alpha. Then pi of alpha differentiation is pi dash of alpha integral 0 to infinity e to the power of minus x square by 2 dou by dou alpha cos alpha x dx. Both side difference is with respect to so partial it is. Dou by dou alpha it is partially. Pi dash alpha as it is integral 0 to infinity e to the power of minus x square. Here with respect to alpha is there. So what will get it? Cos alpha x is minus sin alpha x. With respect to alpha means it is x will get it. That is equals to integral 0 to infinity sin alpha x minus x e to the power of minus x square by 2 into dx. Now here again using the integration by parts. Sin alpha x as it is e to the power of minus x square by 2 integral 0 to infinity. Here sin alpha x is the first, this is second integral. So integration of integral 0 to infinity e to the power of minus x square by 2 alpha differentiation of this again alpha cos alpha x dx integration by parts. So again here e to the power of minus x square by 2 is a substituting upper limit will get totally 0 and x is there. Then here sin 0 value is also 0. E to the power of minus 0 value 0. When substituting lower limit sin 0 value is 0. Totally it is 0. Then this integral, this alpha is right outside the integral. integral 0 to infinity e to the power of minus x square by 2 cos alpha x dx. This value is pi dash of alpha value. Then pi dash of alpha is equal to minus alpha pi alpha. Why? Look here. This integral is same as pi of alpha. The integral. So minus alpha into pi of alpha. Pi dash of alpha is equal to minus alpha pi alpha. Or this is, you should take left hand side. You will get pi dash of alpha divided by pi of alpha is equal to minus alpha. So integrate both sides with respect to alpha. Then integral of pi dash of alpha divided by pi of alpha d alpha is equal to minus integral alpha d alpha. This is the integration constant. Then here numerator is the differentiation of denominator. This integration will get log of pi of alpha. Like it is integration of f dash of x by f of x dx is log of f of x, like this. Log of pi of alpha minus alpha difference integration is alpha square by 2 plus c, or pi of alpha is equals to, you write in the exponential form, then we'll get pi of alpha is equal to e to the power of minus alpha square by 2 plus c. Then pi of alpha is equal to k times of e to the power of minus alpha square by 2, where k is equal to e to the power of c. Here we write e to the power of minus alpha square by 2 into e to the power of c. That is, we consider e to the power of c is k. To evaluate this c value, our value is to find the c value, then put alpha is equal to 0. Here, put alpha is equal to 0. What will get it? Both sides. Pi of 0 is equal to e to the power of minus 0. Alpha is 0 means pi of alpha is equal to k. But pi of 0 value is integral 0 to infinity e to the power of minus x square by 2 dx. Pi of 0 value. So both equal here, pi of 0, pi of 0. Now here, to evaluate this integral, just take the substitution. X divided by root 2 is equal to t. Then differentiate x with respect to t. Then you will get dx is equal to 2 root 2 dt. Then pi of 0 is equal to t is equal to 0 to infinity e to the power of minus t square. Because here x by root 2 is equal to t means minus x square by 2 is a t square. Root 2 dt. This is dx value. Dx value is 2 root. But integral 0 to infinity e to the power of minus t dt is root pi by 2 is the standard integral. So here this root 2, then pi of 0 is equal to square root of pi by 2. This value. How will get it? Actually this integral is root pi by 2. Then root 2, here this 2 is there. Get cancel, you write root pi by 2k. K, how is it at? Pi of 0 is equal to pi of 0. Then k is equal to this thing. Thus pi of alpha is equal to square root of pi by 2 e to the power of minus alpha square by 2. Pi of alpha value here. Pi of alpha is what? Pi of alpha is equal to e to the power of minus alpha square by 2 into e to the power of c. Pi of alpha. Now equation 1 becomes, we are finding the f of pi alpha value here. Fs cap alpha is equal to square root of 2 by pi. Alpha pi of alpha is equal to root 2 pi. That value as it is by definition, this one. Alpha as it is. Pi of alpha is this thing. We substitute here. Root square root of pi by 2 e to the power of minus alpha square by 2. Then simplify this. This is 1 totally. This and this one. Alpha into e to the, here is also e to the power of minus alpha square is not there, but it is there. Alpha e to the power of minus alpha square by 2. Then look here. Alpha e to the power of minus alpha square by 2 is the same form as x into e to the power of minus x square by 2. This means that x into e to the power of minus x square by 2 is the self-reciprocal under the Fourier sign transformation. That's all. So one more simple example. Find the, now here we find the inverse Fourier sign transform. Before all the problems we have solving the Fourier sign transformation, but here inverse Fourier sign transformation of fs cap alpha is equals to 1 by alpha e to the power of minus a alpha, where a is positive. To solve this problem, by given fs cap alpha is equal to e to the power of minus a alpha by a, by using the definition of the inverse Fourier sine transformation, we'll get f of x is equal to, how we'll write this one? It is the definition of the inverse Fourier sine transformation. F of x is equal to fs inverse of fs cap alpha, that is equal to square root of 2 by pi integral 0 to infinity fs cap alpha sine alpha x dx. When here inverse is there, fs cap alpha. If inverse is not there, f of x. Square root of 2 by pi as it is integral 0 to infinity. What is fs cap alpha? E to the power of minus a alpha by alpha, it's substitute. Sin alpha x d alpha as it is. Square root of 2 by pi. This total integral we consider pi of x, where pi of x is equal to integral 0 to infinity e to the power of minus a alpha by alpha, alpha sin alpha x d alpha. And we need to differentiate under the integral sign for the evaluation. This is also, as it is very difficult to find the integral value. So we are using the integral sign. Differentiation under integral sign, we can find this one. Pi dash of x is equals to integral 0 to infinity. What is here? Pi of x. Pi of x is 0 to infinity e to the power of minus a alpha by alpha sin alpha x d alpha. Now differentiate with respect to x. Pi dash of x is equal to, partially here is integral 0 to infinity e to the power of minus a alpha alpha cos alpha x alpha d alpha. That is integral 0 to infinity e to the power of minus a as it is. Here alpha alpha cos alpha x d alpha is there. Then e to the power of minus a alpha 1 alpha, will get it, cancel it is 1 alpha alpha. Then pi dash of x is equals to, this is a standard integral. This value integral 0 to infinity e to the power of minus a alpha cos alpha dx is written as a divided by a square plus x square. So therefore pi of x is equals to, if pi dash of x this thing, then how will get pi of x? Integrate this one time, then integration of pi dash of x is pi of x. Integration and differentiation get cancelled, you get pi of x. Right hand side integral a divided by a square plus x square dx plus c. Then pi of x is equal to, look here, integration of a divided by a square plus x square. It is a standard form, tan inverse x by a plus c. To find the, our aim is to find the value of c. Then put x is equal to 0 here. Here put x is equal to 0. Pi of 0 is equal to tan inverse of 0 plus c. Tan inverse 0 value is 0. So put x is, pi of 0 value is what? Pi of 0 value is also 0. Pi of 0 value is 0. Then c is equal to 0. Once we know c value, we can put in this formula. Pi of x is equal to tan inverse of x by a, is c is 0. Hence f of x is equal to square root of 2 by pi of x. What is pi of x? Tan inverse of x by a. The square root of 2 by pi tan inverse of x by a. Now one more example. Find the Fourier sine transform of alpha divided by 1 plus alpha square. Given fs of f of x is equal to fs cap alpha divided by 1 plus alpha square. Here find the inverse. It is inverse is there here. It is this arrow mark, it is inverse. It is not seen, but it is inverse. By the definition of the inverse Fourier sine transformation, this is the definition. F of x is equal to square root of 2 by pi integral 0 to infinity fs cap alpha sin alpha x d alpha. Then as it is only fs cap alpha, you substitute here. Alpha divided by 1 plus alpha square sin alpha x, sin x alpha d alpha. Then f of x is e to the power of minus x square root of, here actually f of x is e to the power of, here transformation of the function f of x is equal to e to the power of minus modulus of x is there here. Here transformation of, then f of x is equal to e to the power of minus x, x is greater than 0. So that is why we have writing here f of x is equal to e to the power of minus x. This is same as it is, there is no change. Then root 2 by pi, you take left hand side, write the reciprocal of this, e to the power of minus x divided by root pi by root 2, integral 0 to infinity alpha divided 1 plus alpha square sin alpha x d alpha. Then integral 0 to infinity alpha divided 1 plus alpha square sin x alpha d alpha is equal to square root of 2 by pi e to the power of minus x. Now this is the fs of f of x. Then f of x is equal to square root of pi by 2 e to the power of minus x. Find the inverse Fourier sine transformation of fs cap alpha is equals to fs cap alpha is equal to 1 by alpha e to the power of minus a alpha, where a is greater than 0. By the definition, fs cap is given. We have using the Fourier sine inverse formula. This is the Fourier sine inverse formula. Square root of 2 by pi integral 0 to infinity is fs cap alpha is e to the power of minus a alpha by alpha sin alpha x d alpha as it is. Square root of 2 by pi, again this integral we consider pi of x, where pi of x is equal to integral 0 to infinity e to the power of minus a alpha by alpha sin alpha x dx. This is called equation number 1. This integral has to be evaluated by Leibniz rule for differentiation under the integral sign. Then pi dash of x is equals to, pi of x is this thing, integrate, differentiate partially both sides. Then left hand side is pi dash of x, right hand side integral 0 to infinity e to the power of minus a alpha by alpha, then d by dx of sin alpha x dx alpha with respect to x. So integral 0 to infinity e to the power of minus a alpha by alpha with respect to x. What will get it? Alpha, sin alpha x is cos alpha x. Alpha x is also function of x. So it is alpha only. Alpha cos alpha x d alpha. Pi dash of x is equal to integral 0 to infinity alpha alpha get cancelled. E to the power of minus a alpha cos alpha x dx alpha. This is again standard form here. Integral 0 to infinity a e to the power of minus ax cos bx is written as a divided by a square plus b square. Here alpha is there. Here alpha x is there. Alpha x is there. A divided by a square plus x square. So pi of x is equal to a divided by a square plus d square dx plus c. How will get it? Pi dash of x is this thing, a divided by a square plus x square. Then how will get pi of x? Just integrate this one with respect to x. Then pi of x is equals to integral a divided by a square plus x square dx plus c. Pi of x is equal to 1 by a tan inverse x by a plus c. To find c here, put x is equal to 0 here. Then you'll get a get cancelled. Pi of 0 is equal to tan inverse 0. Then pi of 0 is equal to c. From the equation 1, when x is equal to 0, pi of 0 is equal to integral 0 to infinity e to the power of minus a alpha by alpha sin 0 value. Sin 0 value is 0. So pi of 0 value is 0. Then pi of 0 is c. Pi of 0 is 0. Left hand side are equal here. Pi of 0 is equal to 0. From equation 2 and 3, what we conclude that pi of 0 is c. Pi of 0 is 0. Left hand side are equal, right hand side must be equal. So c value is 0. Then this c value substitute here, where it is here. What will get? Pi of x is equal to tan inverse x by a 0. Hence f of x is equals to square root of 2 by pi tan inverse x by a. Now these are the refer the previous example. We can try to solve these examples, and answers is also there here. And these are the examples on Fourier sine transformation. Try to work all these are also sine transformation examples. Here these three are the Fourier sine transformations. Already we have did this and this and this. Try to this one. Okay, dear students. Now let us stop the class here. Then we will discuss next class in the next. ಸ್ವಲ್ಪ